Welcome back to our second probability word problem. A frog sitting at the points 1, 2 begins a sequence of jumps, where each jump is parallel to one of the coordinate axes and has a length 1, and the direction of each jump, which could be up, down, right, or left, is chosen independently at random. The sequence ends when the frog reaches the side of the square, and this square having the vertices at 0, 0, 0, 4, 4, 4, and 4, 0. So what is the probability that the sequence of jumps ends on a vertical side of the square? So we have to first break this problem down. As you can see, we already drew out a quick coordinate plane to show us the path of the frog. This is the square that it's jumping in, and here is its starting point, 1, 2. So this is where the frog is starting. And it can either jump to the, let me move this over a little so we can understand it better. So it could jump over by 1 or jump up by 1 or, the 4 directions that we are given. Now, how do we break this problem down? Well, we know that it can either jump up, down, right, or left. So let's start with the first jump. Okay, let's start with the first jump. Let's first explore what would happen if the frog decided to jump to the left. Well, if the frog jumps to the left by 1 on the first jump, we see that it has already hit a vertical side, right? The two vertical sides being this side and this side of the square. So if it jumps to the left immediately, then it would have already hit a vertical side of the square, and the jumping sequence would have just stopped there. So what is the probability of this happening? Well, we know that with each jump, it can either go up, down, right, or left. And the possibility of it jumping in either of these directions is the same. So the probability for it jumping to the left and then the sequence stopping there would be 1/4. Now let's explore what would happen if it jumped to the right. If, from this starting point, the frog decided to jump to the right side by 1, it would land exactly in the middle of the square, which is at 2, 2. And as you can see, once it gets to the middle, it has a equal chance of going to either the left vertical side or the right vertical side. So how could we express this probability, the probability of this sequence? Well, first we have to make the probability of it jumping to the right. Again, it would be 1/4 because from the starting point, there is an equal chance of you going up, down, left, or right, and in this case it has gone right, so that's already 1/4. Now, our next probability is 1/2, right? Because after getting to the middle is when you have 1/2 of the chance going to either of these vertical sides. So after multiplying these two, we have 1/8. So the chance of this sequence happening is 1/8. Now let's talk about if the frog goes up or down. So here I'll write up or down. And notice how I am approaching this problem with a very organized thought process. If I was just all over the place, I would get really confused really quickly. But by writing it out in clear rows like this and even labeling the directions, it's really helping me stay organized. So let's say that the frog goes up by 1 and lands at this spot over here. As you can see, from this spot, the probability for it to hit a vertical wall now is 1/2. So it's the same for if it goes down, right? If it goes down, it'll just be the same. See how this is symmetrical right here? It'll be the same symmetry, just flipped over. So really it's the same if it goes up or down. So how could we write this sequence down? Well, first I would have to make the decision of going up or down, which would be 1/2, right? Because here we are already containing two directions in here. It could go either up or down. So that's already 1/2. And after going up or down, it has a 1/2 the chance of getting to a vertical side and then stopping there. So after multiplying the two 1/2s together, we have 1/4. After adding these together, you'll see that our final answer is 1/8. So the correct answer for this problem is B.